going to go through the test, chapter 1, for regular PreCAl. We're going to go through the corrections. So number 1, it says to determine whether the given relation represents y as a function of x. So the fastest way to tell that is if I could look at the graph and use the vertical line test. So I'm in a new document, don't save, and I'm going to add a graphs page. And so I'm going to type in the square root of x squared plus 3. And so my graph does pass the vertical line test, so yes, it's a function. Okay, number 2, state the domain and range of the graph below. And so we have an absolute value graph, and we have the equation right here. And we can see that the graph is continuous, and it uses all the x's, so the domain is all reals. Or you can write it in interval notation from negative infinity to infinity. The range only uses values that are greater than or equal to negative 3. Number 3, it says find the y-intercept and the zeros for 4x squared minus 8x minus 12. Well, the y-intercept we know is we have to plug 0 in for x, and so we end up at negative 12. X-intercept, you can factor or look at the graph or use quadratic formula, whichever you like. I'm going to factor. So I'm going to pull out the 4 from all 3 terms to begin with. So I get x squared minus 2x minus 3. Continuing to factor gives me 4 times x minus 3 times x plus 1. And so my solutions are negative or positive 3 and negative 1. Determine whether the function is continuous at 3. If it's discontinuous, identify the type of discontinuity as infinite, jump, or removable. So it's always nice to be able to look at the graph. So that's what I'm going to do. So I'll type in x minus 3 in the numerator and x squared minus 9 in the denominator. And we'll look at the graph. And so our question is at 3, so at 1, 2, 3, it appears to be continuous according to the graph, but we want to make sure, so I'm going to look at the table. And so when x is 3, it is undefined. So in the table, I know that when x is 3, it's undefined, but according to the graph, it appears that it is continuous. So I know from the table that it is discontinuous at x equals 3, and the type of discontinuity is removable because the calculator has removed that hole. This is removable. Graph appeared continuous, but the table says otherwise. It is undefined at x equals 3, so that is removable discontinuity. Number 5, determine the maximum and minimums for f of x equals x cubed minus 2x and classify them as absolute or relative. So I'm going to type that equation into my graph. Get rid of what was in there. And I'm going to type in x cubed minus 2x. And so we have a max and a min, and these are relative max and relative mins because there are points on the graph that are higher than that, and this is a relative min because there are points on the graph that are lower than that. So they're both relative, so we're going to find the max and the min. So go to menu, analyze the graph, and I'm going to find the maximum first. So I'll skip this over here. So there is my relative max. And so I have relative max at negative 0.816, comma 1.09. And I know I'm going to get a relative min. So I have to go through the process again. I have to go to the menu, choose Analyze the Graph, and this time I'm going to choose Minimum. So we're going to trap it in between those dotted lines. Click. And so there's my minimum. It's going to be at 0.816, comma negative 1.09. So I might just draw this graph here. And so I know that I'm going to, the next question is asking me to determine the intervals on which it's increasing and decreasing. Same function. And so intervals are created using x's. So when you're talking intervals, you have to determine what x is. So as I trace the graph, I'm going increasing, and I know that this maximum, the x value was at negative 0.816. So I'm going to increase from negative infinity x value to negative 0.816. Then my pencil traces down, so I'm decreasing to the minimum, which was at 0.816 x value. So I'm decreasing between negative 0.816 to positive 8.16. So I'm decreasing from negative 0.816 to positive 0.816. Then my pencil goes up again, so I'm increasing again from this x value, which is 0.816, out to infinity. So remember, intervals are created using x values, not y's. Number 7, identify the parent function and describe the transformations. Well, this is x cubed is the parent function. And the transformations, the negative out front gives me a reflection over x axis. The positive 3 is a horizontal shift to the left, 3 units. Numbers 8 and 9, we're going to be using the functions f of x equals x minus 6 and g of x equals x squared minus 36. And so we're asked to find each function in its domain. So in number 8, it's the quotient of f divided by g. So we have x minus 6 is f divided by g, which is x squared minus 36. And so we know our domain restrictions come from the denominator. And so I'm going to set x squared minus 36 can never be 0 because I can't divide by 0. So x squared cannot equal 36 because I add 36 to both sides. Taking the square root of both sides, x cannot equal plus or minus 6. So that's the domain restrictions. You can also see this on the calculator. All right, so we can look at this on the calculator as well. Get rid of this one, the old one, and type in our x minus 6 over x squared minus 36. And so I see one of the restrictions here at 1, 2, 3, 4, 5, negative 6. I have a vertical asymptote here. But at positive 6, it's a little harder to see, so I need to go to the table to make sure that I have this right. So I'm going to check negative 6 first. Negative 6, sure enough, is undefined in the table. I'm going to go check positive 6, and it's also undefined in the table. So those two values we cannot use for x. We can never put in 6 or negative 6 because we're going to get an error in our calculations. So you could simplify this. This would be okay for an answer, but better, this is good, better would be x minus 6, factor this to be x minus 6 times x plus 6, because this is a difference of perfect squares. And so this now becomes 1 over x plus 6. All right, number 9 is composites, g of f of x. So I'm going to put f into g. So that means I'm going to have parentheses squared minus 36. And so what goes in here is f, which is x minus 6. So remember when you're squaring this out that this x minus 6 squared equals x minus 6 times x minus 6 minus 36. So I end up foiling it out. I get x squared minus 6x minus 6x plus 36 minus 36. Opposites cancel, combine your like terms, and you end up with x squared minus 12x. And the domain is going to be all reals. And the last one, number 10, determine whether f has an inverse function. The key word there is function. If it does, find the inverse and state any restrictions on its domain. So the quick way, or what we always did when we were checking these, is we checked using the horizontal line test. So I want to graph this to see if it will pass the horizontal line test. So I'm going to type in x squared minus 16. And it fails the horizontal line test because when I draw a horizontal line, I hit the graph in 2 places. So fails horizontal line test, therefore inverse is not a function. And that's it. So good luck on your corrections. Make sure you have them turned in by Friday, August the 16th, I believe. All right, good luck.